Hello everyone, welcome back to my mathematics channel. For today's lesson, I will start with Form 5 KSSM Mathematics New Syllabus Chapter 1. So we are under dual language program. So I'll be teaching 100% in English. So let's get started with the class. So before that, I would like to introduce to you the new textbook. It actually looks very attractive and interesting. So you will have the cover of the textbook in pink color. That's pretty nice color. Alright, so this is the Mathematics Form 5 for DLP. So I will actually just start chapter 1 for the variation later on. So these are a person who involved in creating the textbook. So congrats, this is a very attractive and creative textbook. So chapter 1 is variation. So for variation, we have three types. One is direct variation, followed by inverse variation, and we combine the two, direct and inverse, it becomes combined variation. So this topic is pretty easy, but you need to understand the concept behind variation. Is very interesting if you understand the concept. For chapter 2, we have matrices, also very easy, and we have consumer mathematics, insurance, and we have the congruency, enlargement, and combined transformation. Congruency, enlargement, combined transformation, and tessellation is a totally new syllabus, which is very interesting. Then we have statistics, we have mathematical modeling, which is also very interesting. So in short, the Form 5 syllabus sounds very interesting. So the textbook is so nice, so colorful with all the information and symbols, right? And this is the formulae that you should actually memorize, just a few formulae. Okay, so chapter 1, variation. So we will start with chapter 1 now. So what will you actually learn for this variation? You will learn direct variation, inverse variation, and combined variation. So the first one is direct variation, is very easy, and inverse variation also very easy. Combined variation is easy plus easy, so it's very easy. So why we need to study this chapter? The concept of variation is commonly used in our daily life and in the fields of science and mathematics. For example, finding the distance traveled in terms of speed and given time. Investigating the relation between the depth of the sea and the water pressure and others. So do you know the symbol was introduced by William Emerson. Guys, have you ever seen this symbol? It looks like the awareness of the health, right? So for more information, you may scan the QR code. Alright, so let's see the World Bank. Okay, this is an important keyword. So we have constant, variable, we have combined variation, direct variation, inverse variation, and joint variation. So we have 1, 2, 3, 4, 5, and 6 keywords. So I will explain to you later on when we start the class on variation. So these are the intro for the use and application of the variation in our daily life. Example for research, the electrician conduct experiment to investigate the relation between two or more variables. So the next one is actually direct variation. So what is the meaning of direct variation? So I will explain the meaning of direct variation using the picture. 5 cups of rice for 10 servings. So if 10 cups of rice, we actually need for 20 servings. That is called direct variation. So a chef needs to decide the amount of ingredients to be used according to the number of servings. If the ingredient used increase, then the number of servings increases. On the contrary, if the ingredients used decrease, then the number of servings decreases too. So again, ingredients increase, number of serving increases. Then if the ingredient used decrease, then the number of servings decreases too. So in our daily life, we often face situations that involve the relation of quantity changes. For example, the distance traveled and the taxi fare, right? Alright, so these are the example and the table. Now this relation is known as direct variation. In general, direct variation explains the relation between the two variables, such that when variable y increases, the variable x also increases at the same rate and vice versa. The relation can be written as y varies directly as x. So y varies directly as x. So example, the total wage of a part-time worker as a promoter varies directly as the number of hours worked. State the change on the total wage if the number of working hours is double. So if number of working hours is double, so the total wage is double. If number of working hours decrease by 40%, then the total wage also decreases by 40%. If number of hours, if the total wage is half, then the number of working hours also follow, right? So this actually quite simple example. So you may go through the example, and I will actually share with you the video teaching conducted by US teachers later, so that you can have a better understanding of the direct variation, alright, and also inverse variation. So for today's lesson, I will actually focus on direct variation, and as you see, when you do the calculation, the value of y over x is a constant. So the graph of y against x is a straight line, alright. So this is a straight line. It shows that y varies directly as x. Okay, so the relation is truly only if the straight line passes through the origin. So in short, k, the constant, is actually you take the value of y divided by value of x. Okay, if y varies directly as x, the relation is written as y varies directly as x. So from the relation, we can find the constant of proportionally k can be determined, that is k is y over x. So for a direct variation, y varies directly as x can be written as y, we call as the symbol looks like ribbon, y ribbon x. So it's actually y varies directly as x. So you can actually convert into equation y equal to kx, where k is a constant. So you can actually try to explore more on the example given. So the first question, maybe they will give you a table, then you check the constant. If the constant are not the same, then it shows that it's actually not varies directly. If you can find the constant, you take the y over x, you can find the constant, that means it is varies directly. So the straight line actually does not pass through the origin, alright? So y does not vary directly as x. Alright, so there are more examples for you to go through. Okay, so when come to the new textbook, it's actually you will have more example for you to explore. So example m varies directly as n, so m is equal to kn, then you solve to find the constant, substitute the values, okay, of m and n into the equation and find the constant. After you find the constant, then you can express m is equal to 6.4n. Same thing applies for example b. Alright, so every time when you do variation, you have to find the constant, write the relation in the form of equation. Alright, after you find the k, you have to write the relation in the form of equation, substitute the values of x and w, okay, into the equation to find the k. Alright, so actually it's quite simple for variation. So the example here are quite good. You can go through on your own. Alright, so you can also do the exercise when you are free, so that you can actually gain more confidence and you have less mistake when it comes to mathematics. Alright guys, I'm going to share the video conducted by US teacher about the variation. So have fun.
It is inversely proportional to each other, the two variables. Then one variable has to be at the numerator, while as the other one has to be at the denominator, vice versa. If they have if it's a direct variation, then both of them will be on the same side. So either both on the numerator or both at the denominator. Usually it's both at the numerator. Okay, so let's take a look. Over here we have b equals 8 of a. Turning them into fractions, we have b over 1. Let me write it nicely. We have b over 1 and negative 8a over 1. Okay, so both b and a are on the numerator. So that is a direct variation. Okay, now if you remember the formula for a direct variation, that's even better, because the direct variation has the form of b equals, let me actually use x and y. Okay, so y equals k times x. Okay, so here the y corresponds to the b right now. K is our negative 8, which is the so-called constant variation, right? And the a corresponds to x. So this is why part A is a direct variation. M equals n over 5, right? Convert everything into fraction. N over 5 is already in fraction, so that's fine. M converted into fraction, we have m over 1. Now, let's take a look. M, it's on the numerator. What about the n? N, it's on the numerator as well. Since they both are on the numerator, they have a direct variation. Okay, so we have a direct variation. Now, if you want to convert this back into the standard form, y equals k of x. Okay, so this, it's actually m equals 1 over 5 times n, where the k, the constant of coefficient, it's 1 over 5, right? So the k is 1 over 5, the x is our n, and the y is our m. So this, it's a direct variation. C. Part C, we have p equals negative 2 over q. Convert everything into fractions. P is p over 1. This is already in fraction form, so we're good. Let's take a look here. P, it's on the numerator, and our q is at the denominator. They are on opposite sides, right? One's numerator, one's denominator. So we can conclude that this is an indirect, okay, indirect variation, or the so-called inverse variation. Okay, so how, if we want to convert it into the form, indirect variation has the form y equals k over x, right? So here we can rewrite it as p equals negative 2 over q. Okay, so it's actually already in the form. Okay, so this is actually already in the form, just rewriting it. Okay, so this is the standard form, and it is the standard form of the indirect variation, or the inverse variation. Okay. Last one, part D. We have s equals 1 over 7 times t. Well, again, convert everything to fraction. It's s over 1 and t over 1. Both the variables are on the numerator, so this is a direct variation. Okay, direct variation. This is our y, and k is 1 over 7, and our x is our t. So this is the direct variation. To identify the indirect variations on a graph. Okay, so here we have part A and B. We want you to classify the following graphs as well. Okay, so determine if it's a direct or indirect variation. Okay, so before we start, let's quickly do a review again. What is a direct variation? Direct variation happens when the two variables have a direct relationships. That means if one of the variable increases in value, so will the other one. Okay, so let's say we use x and y. X increases in value, y increases in value as well. Indirect variation means that with the two variables, if the value of one variable changes, let's say it increases, the other one will behave oppositely. So if the one variable increases, the other variable will decrease. So they have the opposite or inverse relationship. Okay, so we have x increases, y decreases, vice versa. Okay, so you get the idea. So let's take a look at part 1, graph A. Here, let's say we pick this point. Okay, that's around x equals 1, y equals 3. Okay, so as x increases, what happens to the value of y? As x increases from, let's say, 1 to 2. Okay, so 2, it's somewhere here. Okay, so we get from this point to this point, we increase in the value of x. What about the y? The values of y increases as well, right? So horizontally, it increases in value, and vertically, it increases in value as well. So since both the variable increases, that means it's a graph for direct variation. That's how you distinguish between direct and indirect. Okay. Again, we want to use the same approach to determine for this graph. Okay. So first of all, let's say we start with this point over here. We have this point around 1 and 1. Okay. X equals 1, y equals 1. Now, when the value of x increases, what happens to y? So if we increase the value of x from 1 to 2, where's the value of 2? 2 is right here. Okay, so if we increases the value of x, so increase, okay, by 1 unit, what happens to the y, the vertical? The vertical change is a decrease. So you see, from this point to this point, you are actually decreasing in the value of y. Okay, so this concludes that when you increase in value of x, the value of y will decrease. Increase, decrease. They are having an inverse relationship. So that therefore this is an indirect variation graph. Right? The time it takes to fly from Canada to China, both the seas, varies inversely as the speed of the plane. So we know we're dealing with an inverse variation here. If the journey takes 13 hours at 950 kilometers per hour, how long would it take at 650 kilometers per hour? Okay, so we're flying from Canada to China. We're like on a journey somehow. Okay, so since it's an inverse variation, first step, write out the general variation formula. We will have, let's give us some variables. Okay, so we're looking at the time and the speed. All right, we're looking at time and speed. So let's say time, we give it a variable t. And the speed, we give it a variable s. All right. So now we have the inverse variation between these two variables. So we have t is k over s. The time is inversely proportional to our s. All right. So we have t equals k over s. Next. So this is the step 1. Step 2, find the constant variation k. So we want to find k. If the journey takes 13 hours. So if the t is 13 hours, let me actually use a different color. Okay, to make it better for you to read. So if the t is 13 hours, then the speed will be 950. So just plugging them in, and we can be able to solve for the k. T is 13, so we have 13 equals k over speed is 950. So now we want to solve for k. How do we solve for that? Multiply both sides by 950. 950 here, so that's these two canceled out, all right? So right hand side we just have a k. Left hand side we have 950 times 13, which is 12350. Not 12345. It's 12350. 12,350. That's the constant. Okay? So we're done with the step 2. Step 3, we want to update the formula using the answer for k. So updating it, we will have t equals, k is now 12350. So we have 1250 over s. That's our updated equation. Right? Cool. Last one. Solve the problem by inputting the known information. So now what's the question? The question is how long would it take? So we're looking for the time as 650 kilometers per hour. This is our speed, right? So plug 650 into this, we will be able to find the time taken. So we have 12350 over the speed, which is 650. All right? So plug this into the calculator, we will be getting 19. Okay? So at 650 kilometers per hour, the time it takes would be 19. Unit is what? It is hours. Okay, so don't forget the units. In the word problem, there's always a unit. So it will take 19 hours to fly from Canada to China at the speed 650 kilometers per hour.
Right, thank you so much for the interesting lesson. I look forward to see you all in my next video sharing. Till then, bye bye and have a nice day.